under the hints for being successful at this topic, I really encourage students that if you have to write the formula or the name of an ionic compound, I really think you should write the component ions. So, for instance, write the component ions of the compound sodium chloride, and actually it would be Na plus 1 Cl minus 1. Component ions of this. Now you're like, oh my gosh, you could be faced with this on a test and you're like, I have no idea. Well, look for the cation and the anion, okay, and see if that helps you at all. Can you see ammonium, NH4 is the cation and NO3 is the anion. So the component ions look like this. They're two polyatomic ions, NH4 plus 1, NO3 minus 1. Let's see. Again, you're like AI? What's AI? In fact, I've caught myself doing that same thing. Well, actually, it's not AI, it's aluminum. Okay, look for the metal in this case, and then nitrogen is the non-metal. Okay, so write the component ions. Aluminum is a 3A metal, so that's an Al plus 3, and nitrogen is an N minus 3. Okay, now in this case, you know it's Fe, okay, iron, right? And you know it's Br minus 1, but you don't know what the charge of the Fe is. This is actually one of those where you can kind of do a little bit of, how do I say, kind of detective work on the back end. So if we know it's Br minus 1 and it's Fe question mark, because we saw it's a plus 2 or a plus 3, okay, notice that if we go plus 3, actually that makes sense with what we saw in the formula. So this is an Fe plus 3 and a Br minus 1 for the component ions. One more on this page. Now that's my nemesis. Remember, we're looking for the cation and the anion. This actually is an example of a polyatomic ion. That's that Hg, remember I did it like this, Hg, all running around with a plus 2 charge. That actually is mercury 1, polyatomic cation. Grr, okay? So that's it for that page. Do a similar thing here. Break this down into its component ions. Of course, that potassium is simply a 1A element, so it's plus 1. Bromine is 7A, so it's minus 1. Component ions of this one. So Li is going to be our metal, our monatomic ion, and NO2 must be our polyatomic anion. Okay, and you can tell actually it must be a minus 1. That's nitrite. Now this one, aluminum is a plus 3, sulfur is a minus 2. Actually, you can kind of see how we are getting we can crisscross from our red ones to get our blue ones. Now nickel is one of those transition metals, and it's not, remember there are 3 transition metals, silver, cadmium, and zinc, that we don't use Roman numerals, but we're going to have to use Roman numerals for this one. Again, if we kind of do a little bit of deductive reasoning, we may not know what the charge of the nickel is, but by golly, you know the charge of the chlorine. Each chlorine's a minus 1, and there are 3 of them. So what is your nickel got to be? Actually, it must be a plus 3. So writing the component ions can help you actually when you go to name the thing. So this actually is simply the monoatomic cation mercury. So it's an Hg plus 2. Now, once you write the component ions like we kind of did before, then we can go ahead from this and write the names. So what do you think? Do we need Roman numerals with sodium? Nope. And instead of chlorine, it's chloride. So sodium chloride. That's probably one you already knew. The next one, you're going to have to be able to name that. It has 2 names. The cation name is ammonium. The anion name is nitrate. Now, how do you know that? You're going to have to memorize that. I've got, like I said, I think I might have said I've got some flashcards to hand out during lab. Aluminum, do we use Roman numerals? No, we do not use Roman numerals because it's a 3A metal. And instead of nitrogen, it's nitride. So no Roman numerals, so aluminum nitride. Iron. Do we use Roman numerals? Yes, we use Roman numerals. It's a transition metal, and it's not silver, zinc, or cadmium. So it's going to be Roman numeral 3. So iron 3 instead of bromine, bromide. Okay, and I kind of already said a minute ago that Hg2, 2 plus, what is the name of that? It's mercury 1 polyatomic cation. So mercury 1, what's the last name? Sulfite. Mercury 1 sulfite. Whoosh. Let's take a look at these. There's our component ions. So potassium, do we use Roman numerals? Now again, you're either going to get this right if you use Roman numerals. Well, how do I say this? If you use Roman numerals and you're not supposed to, you get it wrong. If you don't use Roman numerals and you were supposed to, you also get it wrong. Potassium, no Roman numerals. It's 1A. Instead of bromine, it's bromide. So potassium bromide. How about the next one? I got lithium. Do we use Roman numerals? No, it's 1A. And then the name of NO2 minus 1 is nitrite. Lithium nitrite. Aluminum, no Roman numerals. Instead of sulfur, it's sulfide. So aluminum sulfide. Do we use Roman numerals on nickel? Yes, we use Roman numerals on nickel. It's not 1A, 2A, or 3A, and it is it's not zinc, cadmium, or silver. So we have to go nickel 3 chloride, and then the last one, it's going to be, do we use Roman numerals for mercury? Yes, mercury 2 sulfate.